Hello everyone, welcome back. Now this is our follow-up question of our previous video, which is short search in a sorted matrix. So we are going to do the coding part of that particular question, and we have already discussed all the logical approaches and how we are going to solve that question in our previous video. Now we are do the coding part. As you can see, we have the main function. Inside the main function we have a matrix, a 2D array with these elements. Now we will make a private function first. We will make a boolean function so that it will return if either the keys exist or not. Okay, so for that we will call that function. Before calling that function, we will make that function. So our function name should be search sorted. Okay, and that we will pass our matrix. Okay, so as you can see, I have written a search sorted name here. If I put my cursor here and press control dot, then we will have a quick fix which make a method for us, and we'll copy this private method and put it in here. Okay, we'll make it public, and we'll also change its return type to boolean. Okay, now we can see what it is saying. It result type boolean. Okay, we agreed with that. Return 0 so that we can check. Okay, now first we'll initialize our row equals 0, and we initialize our column, and column equals to matrix of 0 dot length -1. Okay, this is our first row, means first row of this matrix, this one, and this is our matrix dot length dot 0 will give the length of our columns. Okay, now after this we'll create a while loop. In while loop we'll see row should be smaller than matrix dot length, and column should be greater than equals to 0. This condition shows, let me put it in a bracket. This condition shows that it should always work till we reach our this particular index. That means row should be reached to the maximum position, which is matrix dot length -1, and column will reach to from the last element, which is matrix dot length -1 to 0. So till this time we will find in our matrix, and if we found the element we'll return it, otherwise we are not having that particular key which we are having. Okay, so we also should pass here a key which will be given to us, which is an integer key. Okay, and we also pass it from here. We'll make it int key equals suppose we are finding for 70. Okay, and pass it here also. Now in the while loop we check if the matrix of row and column equals key. That means whenever we found in the matrix of the index row and column point, which is I and j, we'll simply return system.out.println the key is present at index row, which is row and column. Okay, this will return us the particular point where we will get, or particular index where we will get our key. So now for the next part, what we're gonna do, we simply return true. That means it will come out of this function by just after printing and back to the main function. So return true, that means we found a key. So if we have seen that if our key is smaller that particular index which we are in right now, then what we're gonna do, we'll minus column. And if we reach to certain point where our key is greater than our particular index of the matrix where we are right now, then we'll do row plus plus. Okay, so for that we do the else if part, else if, and if key is smaller than our matrix of row and column, then we do column minus minus. We have already discussed logic behind this in our previous video, you can check it out there. And else, otherwise we do row plus plus. Okay, and after this all thing happen, what we gonna do, we simply print the key is not found, the key is not found, and return false. So let's run this code. We have searched for 70, as we can see 0 1 and column 0 1, row 1 में, that means this one row, this row, and at the column 2 0 1 2, that means 70, that means the key is present at 1 comma 2. So this is how we found. Suppose we have put the key which is not present in this, which is suppose 123, then it should return the key is not present in this matrix. See, the key is not found. This code is working perfectly. Thank you. Keep learning.